This conference will now be recorded.
Hi guys, good morning and good evening. I hope you are able to hear me. Anyone please confirm?
Yes, Bhaskar.
Okay, perfect. Yeah, so this is Bhaskar. I have 13 plus years of IT experience and I started my career with MSBA and later I got an opportunity to work for Azure Data Factory and Azure Databricks and I worked for Microsoft for 8 years and currently I'm working for one of the Indian based company. So this is briefly about me. And before starting about this Azure data engineering, do you have any idea about ETL tools or any prior experience that you're having? What is the use of ETL or what is the roles and responsibilities of a data engineer? Okay, so why we are going for Azure Data Factory that I wanted to take you through. Okay, so anyone aware of ETL? What is the purpose of ETL? Okay, no problem. So before Hadoop or before I mean to say new generation ETL services, before that we are having SSIS from the Microsoft. SSIS also is one of the ETL tool. So where exactly we used to use this kind of tools is when you run the business, if you want to get insights on top of the business, if you wanted to expand your business from different locations to different locations, or if you wanted to expand your products, different kind of products, if you wanted to expand, then we need to know about how customer feedback or how exactly people are talking about our products. So if you know that, then only can go for expanding. So we cannot just go for expanding of your business. So in order to know what is happening in my business, then we need to have a information. We need to have all the data. We need to take it. Day to day transactions we are going to take, and we are going to save. We are going to do some massage for the data, and then we are going to get the insights on top of your business data. Okay, so we require this thing, then only we can get the information. We cannot directly take the raw data and getting information is not at all is going to be happen. So that I'm going to talk about it. So that means when you have the data in a different data sources at different kind of platforms, if you have, then we need to consolidate all this data. We need to integrate this data. We need to apply data transformations. So once you get the shape, then we are going to get the insights on top of the business. So based on the insights, the users are going to understand the business. The information is going to help us to understand the what it is happening. So based on that, the users are going to decide whether we need to go for expand or not. Okay, so this are all going to be happen regular basis. So that is what we are going to provide the data to the reporting team. Okay, so when you have a reporting team, so reporting team is going to visualize the data, but how exactly they are going to get the data is by using data engineers only. That means our main responsibility is to provide the cleansed data to the reporting team. Clean the data to the reporting team. We are going to provide it. Now, I'm just going to give some brief idea about it. Like what we are going to discuss as part of this is what is data? Where exactly we are going to get the data? So I'm going to talk about it. And when we are getting any transaction, definitely we need to store somewhere else. Okay. So where exactly we are going to store? What is this database that we are going to talk about it? And then ETL processing, I'm just going to give some brief idea about ETL processing. And then information, we're going to talk about it. And then we're going to say what is cloud computing, why we're going for the cloud, why don't we do everything from on-premise. So that we are going to say as part of this. And finally, we are going to talk about the roles and responsibilities of a data engineer. So as I said, data means it's a collection of raw facts. So when you order a product in Amazon, you're going to select what product you wanted to do, what products you want, how much quantity you want, what is the delivery location, okay, and what is the payment mode. You have to make a transaction, right? So this entire thing is known as transaction. When you order product, it's a transaction. When you transfer amount from one account to another account, it's transaction. When you book a ticket, is a transaction. So the respect to business or respect to users of the business is going to collect the business data. Whatever the transaction you've done, those transaction data is going to be captured. So that data we can have in numbers, we can have a date, that means on which date you made a transaction. The customer details is a text. Okay, so date will be there and numbers will be there. This all the raw data is going to be collected from the business applications. So that is what the data we can say. So data is a collection of raw facts in the form of rows and columns. We are going to have it. Okay, so there will be semi-structured data, unstructured data, and structured data. I'm not going into that particular area at this point of time. We are going to talk about it. And then example, as I said, numbers, characters, audio, video, images, all these are the data. So let's say, for example, when you have a business, definitely you are going to have some applications. So that application is going to talk to your business system to store day-to-day transactions. To store the day-to-day transactions, it is going to talk to that. If you take any business in the market, they will be having their own application, and that application is going to talk to the data store. So that means you may have your business data in the database, and you may have data in the form of XML also. Okay, so XML is a lightweighted file. You may get the data from the upstream systems in the form of XML or in the form of JSON files. Okay, so these are all we can call them as data sources. All these things are data sources. So whatever the data it is, you may have a structured data, you may have a semi-structured data, you may have unstructured data. You have to process it. You have to make a structure. You have to make a structure and give it to the reporting team, and reporting team will take care about it. So for that reason, we are going to collect the data from the different data sources. How this data sources collecting the data is out of the boundary for us. The business applications will take care about it. So when you make a transaction in ICICI Bank, you know how we can do transaction in the front end, but what happens in the back end, we are not aware of it. We don't need to know it. So from where I need to bring the data, that is our job. From where I need to bring the data and how exactly I need to save it. Tell me your requirement, I'm going to save the data. So that is what we are going to do it. So your business data is there in all these data sources. Just imagine, and I wanted to create a report. Okay, so the report may be a tabular report in the form of table, you may have it, or in the form of chart, you may have it. The charts may be anything. Okay, so the charts will give more clear cut information to the business users in order to take the decision. Okay, so whatever the reason it is, these are all we can call them as a reports. These are all the reports. Who is going to create a report? A data analyst is going to create a report. We are not responsible to create the reports. Okay, so to this reporting team, as a data engineer, we are going to provide the data to the reporting team. So as a user, the reports are going to be extracted and they're going to understand the business what it is happening. So as a data engineer, we are going to ingest the data by taking data from here. So to where we are going to ingest is, in this particular case, the data is distributed. It's not in a single place. The data is distributed across different platforms, different systems. Okay, so we need to bring and keep it in one place. So previously the data volume is very less. 10 years ago, the data volume is less. So there was no big data. There was only data. So the previous systems, I mean to say the older ETL tools will support to process the data. So what happened is the data is getting increased day by day and data becomes big data, and big data means a data which cannot be stored and data which cannot be processed. We can call that as a big data. So in order to process that kind of data, the older ETL tools are not suitable. So because of that reason, Hadoop came into picture. On top of the Hadoop, Spark came into the picture. On top of the Spark, a Databricks came into the picture, and Data Factory came into that. So like this, that services evolve like anything in order to process huge volumes of the data. So I'm just going to centralize the data here. What is the storage? We'll talk about it. This is just imagine this is some storage. I'm just keeping data in one place. Okay, so when I'm keeping it, I'm just going to apply transformation, depends on the business requirement. So what kind of service I'm going to use is just ignore at this point of time. The process of ingesting the data, we can call it as an extraction. We're extracting the data. And then I'm going to apply transformation with some services or with some tools. What tool it is, it just ignore it at this point of time. And I'm having here the cleanser data here, and we can give this data to the model. We can give this data to the model, and reporting team will take care about how exactly they wanted to create a report. So this part, just observe this entire part up to here. Of course, we are not going to build this. We are giving this to the different people. I mean to say, data analyst team will take care about it. Ingesting, transformation, and loading in the data store. Here itself, I'm just keeping this diagram to store within the storage here. This part will be taken care by data engineer. So Azure data engineer is responsible to collect the data from the various data sources, and applying the transformations depends on the business requirement. And then we are going to feed the data into the storage. Those roles will be taken care by Azure data engineer. So since we are working as an Azure data engineer, the name itself saying that we are going to work with Azure services. Azure services will be used to process your big data. So because of that reason, this part will be taken care by Azure data engineer. And the second part will be taken care by data analyst. Okay, so we are not going to be part of it. If you are already aware of this part, like if you are aware of any reporting tool, then that is fine, but it's not required, and this is not our area. We are upstream systems to the downstream system. So we are going to give the data to the reporting team. So that is what we are going to provide as part of this. Now, basically, I wanted to say previously how exactly the people used to do it before. I mean to say before reporting services, or what we can say before ETL tools, how exactly the people used to do it, and Hadoop. or Databricks, how exactly it was there. I'm just trying to give the brief idea about it. This is all just for understanding how exactly the previously it happened. Nothing more than that. Let's say applications will give the data and keep the data in this particular place. Okay, so you will be having some applications that may be mobile application or that may be web application. So that is going to bring the data and keep the data in the database. That database we can call as OLTP system. The OLTP stands Online Transactional Processing System. Online Transactional Processing System, which is specifically designed for running of the business. If you want to run the business, you need to have a database with online transactional processing. The design of the system is used as ER modeling, entity relationship. Okay, so this is the structure of that. I'm just giving an idea here. This particular system is going to always have normalized data. Okay, so since to maintain normalized data, we need to have a too many tables, we need to make a too many relationships. So this design is not suitable for data analysis. As a business user, I wanted to analyze my data. I wanted to analyze my business, but this is not suitable for that. This is specifically designed for to run the business. Okay, so what happened is, instead of directly bringing the data from this place by reporting team, let's say you have some reporting team, you are not having data engineering team. You just imagine at this point of time. Okay, you have to get some insights. You have to provide, as a data analyst, they have to provide information to the user. To provide that, they have to bring the data from here. They can do it, but this is not recommended because you're trying to get data directly from the business system. So that's going to impact the business. So someone is trying to make a transaction and you're trying to read the data from here, there will be conflict and there will be impact on the business server. So what happened is, basically how exactly the people used to do is, on every day, end of the day, what happened is the business team is going to replicate this, is going to take a backup. They're going to give a backup of your business data at some point of time, so and so time period. On every day they're going to take a backup and they're going to keep at one place. So exactly this system is same as this. Okay, they're going to have a read only access. You're not going to have other than that. And instead of taking data from here, the reporting team is going to take the data from here. The reporting team is going to take the data from here, and you can have a different kind of reporting tools. You may have a Power BI, you may have a SSRS, or you may have a Tableau or any other reporting services. You can use it, but this is raw data. Whatever the business data is there here, the same to same here it is. You have to write a lot of SQL code if it is a database. You have to do many things in order to visualize the data as expected. So because of that reason, this is not suggestible. Okay, this is not suggestible to take the data from here. We have to save the data. Okay, so applications will be provided the data to this particular databases. Okay, so something is happened for my system. Okay, understand. So there is a some changes happen for my file. That's fine. So here, if you observe this, people are going to fill. We are the customers. If you take a bank, we are the customers, right? So you can make a transaction. Those transactions you're doing through the application. That application is talking to the database, and you're keeping the data here. Okay, so that data we are replicating and keeping it in one place for reporting team. Reporting team never get the data directly from the business system. So later that there is some changes happen. The changes like what they're going to do is they have a different kind of data, as we discussed. Different data sources you're going to have. You may have a semi-structured data, structured data, or unstructured data. I wanted to keep all this data in a data lake. So data lake is a use where we can store unlimited volume of the data. Whereas if you go for database, there will be limit. You cannot store. Okay, so even if you wanted to increase the compute, that compute you have to increase vertically. You cannot increase horizontally. So whereas in the data lake, you can expand your compute power horizontally so that you can store huge volume of the data and you can process faster also. So these are all the data sources. I'm just collecting the data from all these places, and this is Azure storage account. So Azure data lake storage is Azure storage account. I'm just going to ingest the data into this place. So I'm not going to directly take the data, and I'm not going to create any data warehouse. I'm going to directly bring and keep it in the file system. This Azure data lake is a file system. We can store any kind of data. If it is a database or if it is a data warehouse, we can store only structured data. Whereas if you go here, you can store any kind of data. So I'm going to talk more in detail about all these things. So for time being, I just wanted to say we stored the data into this particular place as a file one. So that may be XML, even if it is database data, I'm going to convert the data in the form of file. I'm going to convert that particular data in the form of file. So file 1, as a file 1, it is going to store file 2, file 3, and file 4, and so on. So as many files as you want, I'm just going to bring it. Your data source is XML. When it comes to here, that may be any kind of format. The market expected format is Sparky file format. Why it is going to be, we are going to keep as Sparky file format, we are going to talk about it. The size of the data is going to reduce like anything, and this particular storage is specifically designed for speeding up your big data processing. To accelerate your big data processing, they designed this Azure data lake. So we are going to talk more in detail about it. Okay, so we have seen, right, database. What is database? We have come across it. So database is collection of logically related data stored in a single place, that we talked about it. So example for this databases is SQL Server is a database, Oracle is a database, MySQL, NetIsa, and so on. There are many databases. All these databases cannot store big volume of the data. So because of that reason, we are coming out of this to store the data for analysis purpose. So this will be suitable for running the business, not for analysis. So for analysis, we can go for data lake, Azure data lake we can go. Or basically we used to, before that Azure data lake, we used to have a HDFS, Hadoop distributed file system. So there were some limitations are there when you go for HDFS. Because of that reason, we have a ADLS or Amazon S3 bucket. Okay, so like this. Okay, GCP storage. So different kind of storages came into the picture to provide the similar kind of features and to avoid one of the one of the disadvantages here. The disadvantage is this is completely on-prem. Okay, so in order to set up in your premises, it's difficult. Okay, you need to have your own infrastructure or you need to take a data center from the private. So to avoid this same features they brought it into the public cloud and everyone can use it. Okay, so these databases are specifically designed for running of the business, and even previously we used to created data warehouses with those databases also, but now we are not using. We have a different kind of data warehouses came into the picture like Snowflake database Azure data warehouse. Okay, so this kind of data warehouses, the modern data warehouses came into the picture. So we talked about the ETL processing. ETL processing means extraction, transformation, and loading. Extraction, it's a process of taking data from various data sources. Your data source may be anything. Okay, so we are going to bring the data from there. And transformation, depends on your requirement, we are going to apply transformation. So when the business data is distributed, when you're integrating, definitely we need to apply transformation. So in order to apply transformation, what kind of options we are having, that we are going to see as part of a data engineering services. So once you have done the transformation, then we are going to feed the data into the destination. Okay, so if you go for the traditional, as I said, you may have a data in different places, and you can bring the data by using, when you take from Microsoft, we have a SSIS. This is a ETL service. You can take the data from here, and you can apply transformation, and you can store the data into the data warehouse. You can store the data into the data warehouse. The problem here is this service is not suitable to process your varieties of the data. Varieties of the data is not possible to process with your SQL Server integration services, or if your data is very huge, then your SSIS will take days to process the data. If you have a more volume of the data, then SSIS is not suitable to process the data. At the same time, since we are having huge volume of data, we are having a problem to store the data, and we are having a problem to process the data. So how we can store this data? As I said, we are going to use HDFS in order to store huge volume of data, Hadoop distributed file system. So when it comes to the Azure, we are going to use Azure Data Lake Storage Gen 2. ADLS Gen 2 we used to call. The same features of your Hadoop distributed file system we can see in ADLS Gen 2 also. And this is a file system. If you wanted to apply some DML kind of operations, like the way you apply operations on the database, you cannot apply ADLS Gen 2 directly. Okay, so to avoid that, Microsoft came with Azure Data Warehouse. Azure Data Warehouse is going to build on top of ADLS Gen 2. On top of ADLS Gen 2, we are going to create a Azure Data Warehouse. This Azure Data Warehouse is going to allow us to apply DML operations the way your database is going to work. In a similar way, this is going to work. But again, this is not specific. This is not designed for to run the business. This is for analysis only for analysis only. So in place of a traditional data warehouse, they came up with the modern data warehouse. The modern data warehouse is going to build on top of your Azure Data Lake Storage Gen 2. So loading means it's a process of feeding the data into destination. So we have a various ETL tools in the market. There were many ETL tools. Those are all is not going to be suitable. Okay. SQL Server integration services. This is from same Microsoft only, but it is a traditional service, and this is not suitable for the current market requirement. Informatica, data stage, talent. So like this, there were many tools are there. So all these tools are not supposed to process the current required data. So because of that reason, we are looking towards to the next generation services. Give me 1 minute. So we talked about the information also. I'm just giving 3 points here. It's a process of getting insights from the data. We have seen, if you remember, others one side we will be having data and other side we will be having the reports that we have seen. So the report will be in the form of table or in the form of charts, something like that. You're going to have it. So that is what the insights, that is what the information. So users can understand information. Users can understand information. So where we are going to get the where from where we are exactly getting this information is, we are going to get the information from the business data. Whatever the data you're having here, you're getting insights on top of this. Okay, so that was the previous approach that as I said, the new ETL services I just wanted to say. But before that, just imagine I have a requirement, or one of the client reached us to provide the solution for their ETL project. So they wanted to get insights on top of the business. In order to get the insights on top of the business, they asked us to save the data and provide the data to the reporting team. So if this is the case, if you go with the ETL, traditional ETL approach, how exactly it is going to be there? And if you go with the new generation ETL services, if you go, what exactly it is going to be happen? I just wanted to take you through that. So let's say you just take the SQL Server integration services in order to provide the solution for your ETL project, and you need to have a SQL Server integration services, and you required installation, you required license for this, and in order to store the data right after applying data cleansing operations, we need to have a database also. So database is also required. Just imagine, at the time of starting of your project, we decided to go with the 1 TB. We decided to go with the 1 TB database at the time of development. You just imagine, and infrastructure is required. So systems are required, operating systems are required. Okay, networking is required. We have to provide the network for all the systems to provide or to work, and cooling system is required. So this is completely on premise. So we need to provide the security. So we required physical security as well as we required even cyber security also. So that means everything that we need to take care. So run and maintenance, administration activities, all these things we need to take care. Okay, apart from this, at the initial stage you decided to go with 1 TB, but now this 1 TB is not suitable. You have to increase the size of the database. You have to increase the size of the database. To increase the size of the database, just imagine you have to take again a storage. So I wanted to increase up to 2 TB. I wanted to increase up to 2 TB. Then definitely you have to buy hardware, right? Without hardware, you cannot increase it. Without hardware, you cannot increase. So for that reason, you have to spend amount on this. Okay, even if you wanted to increase the compute power for a better performance when there is a more demand, when it is there in the production, you have to increase the compute power. So when you have a on-prem, definitely you're going to increase the compute power vertically. You're going to increase the compute power vertically. That means you're going to increase the hard disk, you're going to increase RAM. So like that you're going to increase it. But that is not going to help you to provide the solution. And moreover, this is completely on-premise. The cost is very huge. This is not cost effective. So to avoid this, we are moving the same solution we can provide from the cloud. We can provide the solution from the cloud for your requirement with less price. With less price, whenever you have a more demand, you just increase compute power. Once your demand is completed, If it is not in demand, then decrease the compute power. So you are going to pay you are going to pay amount for that particular period. That means whatever you have used, for that only you are going to pay. You are going to take a rent. Whatever the services they are providing, you are taking a rent from them, and you're once you have used it, you're paying the rent. It's something like when you stay in the hotel. If you stay for one day, you're going to pay for one day. If you're staying for 2 days, you're going to pay for 2 days. You're not going to pay for entire month. But if you go for on-premise, not for entire month, for lifetime, you're going to pay it. Once you buy a system, you have to keep it yourself only. Okay, you're wasting a lot of amount and you're investing. At the same time, you're concentrating more on the infrastructure than running of your business. Okay, so because of that reason, the people identified the gap here, and cloud platforms came into the picture to provide the solution with less price. You don't worry about infrastructure, you don't worry about storage, you don't worry about installing the softwares. So you can take everything from the cloud itself. With just minutes, you can make ready of your services. You can immediately start your project. But if you go for on-premise, then definitely you have to spend a lot of time to set up all these things. If you go for cloud, if you have a normal system with internet, then you can start doing activities. Okay, so that is what the cloud computing we can call. So cloud computing means you are going to take the services from the cloud vendors. Okay, so I'm going to talk more in detail about that cloud computing and so on. At this point of time, instead of providing the solution from here, I'm going to use Azure Data Factory or Azure Databricks or Azure services I'm going to use to provide the solution for them. So Azure is not only for ETL, Azure is for everyone. Okay, so we are going to talk only data engineering related stuff as part of Azure storages. Sorry, Azure platform. So Azure is a brand where they're selling the services. So as I said, cloud computing means it's a process of consuming cloud services. If I wanted to take any service, I can take a service from here. This cloud is having various services. I'm sitting here. I'm going to take the services from this place. So this may be Amazon, or this may be a GCP, or this may be Azure. So the process of taking the services from here based on my requirement. There are many services, machine learning services are there, analytic services are there, application services, infrastructure services, IoT services. There are many services are there. Whatever the services I required, I'm going to take it. So depends on your project, depends on your requirement. You can take the services from here. So that is what it is saying. It's a process of consuming cloud services from the respective cloud vendors. That vendor may be Amazon, that means AWS, that vendors may be GCP or Azure, whatever it is, you are going to take it. So that process we can call it as a cloud computing. That entire process we are going to have it as a cloud computing. In order to provide the solution for your traditional ETL, we are going to use the Azure Data Factory and Azure Databricks. So we are always talking to the data. We are always going to deal with the data. So as we discussed, the responsibilities of data engineer is data ingestion and data transformation. Those two only two responsibilities. One is data ingestion. In order to ingest the data, you can use Azure Data Factory. Azure Data Factory you can use in order to ingest the data. It is completely user interface, no coding. It's a code-free ETL service or code-free ELT service. So we don't require to write any code. So most of the projects, I mean to say, there were so many projects are there, right, with SSIS or traditional ETL projects, or we can say Hadoop projects. All these projects along with that new ETL projects. Most of the projects are moving towards to the cloud platform. ADF and ADB projects. We can provide the solution for all of this with ADF and ADB. Okay, for data transformation, we can use different kind of approaches in order to process the data. As I said, the first responsibility is data ingestion, just giving higher level, but how exactly can ingest the data? Okay, so how can we bring data from multiple files or single file or different kind of files, or from database? How we can read data from multiple tables? How we can apply incremental loading? So all those things are going to come into the data ingestion. Okay, and the second main responsibility is data processing. So data processing also is very important. This is the main part that we are going to do it. So in order to process the data, the Databricks were there from 2012 onwards. Okay, PySpark was there from 2012 onwards, and Databricks from 15 onwards. The Databricks is there. Okay, so there were many projects with Azure Databricks. So what happened is, to process the data, we can use Databricks, or we can use ADF data flow. This is completely code free. We don't require to write any code. Code free it is. This is 100% coding. It's a replacement of your Hadoop ecosystems. Okay, so maybe if you are aware of MapReduce or Pig or Hive, many things were there. That is going to be replaced by Azure Databricks. Okay, so I'm going to give the more details how exactly it was happened before Azure Databricks and Azure Databricks. So this is 100% as coding, but less number of codings. Okay, by using Azure Databricks, you can ingest the data, you can transform the data. If you have a pure Azure Databricks project, everything we are going to do with Azure Databricks. Okay, so currently the market is how exactly that is looking is, for data ingestion, people are using a Databricks, not only for data ingestion, in order to orchestrate your ETL processing. In order to orchestrate your processing, we are going to use Azure Data Factory. Okay, and we can also use the same data factory to process the data without writing the code. There is a concept called data flow. By using the data flow, we can do it. We don't require to write the code. And there is another way. Before all this, we have a stored procedures. So I did one of the project for data engineering. We have done the entire transformations with stored procedures. For data ingestion, we use the data factory, and for stored procedures, for transformation, for data processing, we used stored procedures. This is also 100% is coding. 100% is coding, but this is bad approach. So when we can go for these approaches, if the user is not in a position to take the license from the Azure Databricks or from the data flow, if they're not in a position, or if they have a very less volume of data, they are not interested to spend the amount, it's just because of easiness. If that is the case, then we can suggest it. So we suggested for one of the client, since they're having completely structured data with less volume of data, and they're not they're ready to spend some time to process the data also. So because of that reason, we suggested to process the data with the stored procedures. This was the traditional approach, but nowadays we are not going to use this. And even that particular user at this point of time, they are taking the transformations with stored procedures, but later, once their business data was increasing, definitely they have to move out of the stored procedures. So as a data engineer, we are going to write the stored procedures. I'm sure about it. If you're having a database as a data source, definitely you're going to write the stored procedures, but not for data transformations. We are going to use the stored procedures for metadata, for handling automation. But we can also do the data transformations with stored procedures. It depends on their requirement. We are going to handle it, and we use this data factory for data ingestion and for orchestration also. We use data factory for one of my previous project. Okay, so most of the projects are having data factory plus Databricks. In some cases, you will be having only Databricks projects. It depends. So in order to understand this data engineering in Azure, I'm specifically calling it this as Azure data engineering. The required services for this is Azure Blob Storage, Azure Data Lake Storage Gen 2, Azure SQL Server, Azure Data Warehouse, Azure Data Factory, Azure Databricks, Azure Key Vault, Azure Key Vault. All these services are required. This is very, very important as we are going to work in real time. This is very important. We need to mask the credentials, how exactly we can mask, but we have to concentrate more and more on these two services. This is the place where we are going to do the process. So storages is just the services will take it to move the data. Okay, so we don't require to work anything explicitly for the storage. But how exactly we can read and how exactly we can process and store the data is important by using the services, not by using any manual activities. So these two are the main responsibilities that we are going to do as part of this. Okay, so that's all about Azure Data Engineering introduction. Where exactly we are going to use and how we are going to do it. We are going to talk, and yeah. So if you have any question, you can ask me.
Hey Bhaskar,
Yeah, hi Subha.
are you able to hear me?
Yeah, I'm able to hear you.
Yeah, Bhaskar, you mentioned we have to use the scripting for the
Mhm.
data ingestion using the Azure Databricks. So, which technology you are covering for the scripting part?
Yeah, that is good question. I'm going to cover PySpark.
PySpark.
Yes.
Okay. Another question.
Yeah.
I heard Databricks will be used for the AWS also. Is it common for both AWS
Yes.
and Azure, or how is it?
It's common. So Databricks basically is a third platform. Okay, third party it is. So they associate because they're not having their own cloud platform. So that's they associated with Azure. They associated with AWS. They associated with GCP. Only these three platforms only they associated. And if you know Databricks, you can work with any of them.
Okay, so you are covering with PySpark in the
Yes.
Databricks, right?
Yes.
For the data ingestion, transformation, and
Yes.
processing.
Yes.
Okay. Thank you, Bhaskar.
Yeah. Anyone else having any question? So
Bhaskar,
I guess yep.
one more,
Yeah, please.
sorry, one more question. So
Yes,
you
please.
mentioned the stored procedures also required sometimes, right?
Yes.
So which level of procedures knowledge is required? At the same time, even To start with the Databricks or the data engineering concepts, which level of SQL knowledge is required here? The basic database knowledge is okay, or we need to have a certain level of proficiency in the database skills? How is it?
We required basic knowledge of SQL because we are not going to make any relationship between the tables. Triggers we're not going to create. Okay, so we are just going to, like, if you wanted to feed some logging details, so instead of directly having insert statement, we are going to keep that in a stored procedure. And we can also write. We have a Spark SQL. Okay, so in PySpark. So the Spark SQL is going to use the SQL standards. So we require like select statement. Whatever the select statement it does, if you are aware of that, that is going to help you. But we are going to talk about it, how we can write select statement on top of the tables. Okay, but if you're already having some idea, basic knowledge is required for understanding that. Like joins, how we can join the two tables. I'm going to cover like if you need more in detail, then I have to spend some time for the SQL.
Okay, are you covering any of the analytics services from the Azure side as part of this course?
Which analytics services?
Or data analytics services, data analysis services?
Your Databricks also is analytics service only. Data Factory. Okay, Azure Analysis
Uh,
Services is there, but that is reporting side. We are not going to be part of it.
oh,
We are going to part of
okay,
data engineering only.
okay. Thank you, Bhaskar.
Yeah. So I can go through the content we have provided. Okay, so how exactly we can, these are all the basic things, what kind of deployment models or types of the cloud services for better understanding, we have provided that. And storage, how exactly we can provide the storage, what kind of storage mechanisms we're having. And we are going to concentrate more on Azure Data Lake Storage Gen 2 and how we can reduce the cost, but we are not going to be part of talking about cost effectiveness. So that will be taken care by Azure administrators, but we are going to have some brief idea about it so that you can also have some idea how exactly we can handle it. And then we're also going to talk about Azure SQL Server, how we can frame that. And this is one of the place that I came across, how we can reduce the cost. That experience I'm going to share with you. So where exactly we faced and how we can go with the budget friendly in order to reduce the cost. And Azure Key Vault, as I said, this is very important as a data engineer. We need to know about it. And then we are going to talk about Azure Data Factory, what kind of components we're having as part of Azure Data Factory, and we're going to talk more in detail about it. And we're having different kind of activities that we're going to touch in order to ingest the data, and how we can get a file system details or database details, filter activity to restrict the data, for each activity, delete, lookup. So different kind of activities in order to orchestrate your end-to-end processing, that we're going to talk about it. And then we are going to do the transformation also, as I said, with the data flow. What kind of transformations we are having? It is looks like same traditional approach, but only thing is you are going to do with the user interface. Behind the scene, you are going to have a Spark only. Okay, so the why people are preferring this is because behind the scene we are going to have a Spark. Even when you go for Databricks, behind the scene you will be having Spark engine to process the data. So even here also, so Databricks is going to do with the coding, whereas Data Factory is going to do with the user interface. So Spark is open source it is. So everyone can take on top of it, they can create their own flavors. So Data Factory took this Spark and they created the data flow on top of it. And Databricks also took this Spark and they created Databricks. So this Spark is completely open source and it is 100% is coding. But when you go for Databricks, you will be having slight user interface will be there. Okay, so that is much more. The people who designed this Spark is designed Databricks also. So I'll give that details later. And SAD type 1 implementation, how we can do with Data Factory. We're going to see the code repository, how we can collaborate the code. As a team, we are going to work. Okay, so how we can share the code, how we can bring the code into the main branch. And so those things we're going to talk here. And we'll provide a sample resumes. You can go through that sample resumes, and we took it from the Naukri, and we will provide it. So interview questions we are going to cover throughout the session, and wherever I'm going to say this is the part we faced an interview question, so that we need to concentrate. And end-to-end project explanation, how exactly the real-time project will be there, that I'm going to explain. And these are all the real-time scenarios that I just mentioned, few of them, but there are many real-time scenarios that we are going to come across it as part of the data factory. And then we have a Databricks. So Databricks, how exactly it was, how we can define that is a big data. Of course, your data factory also will be used to process your big data. And I'm going to talk how exactly that was processed with Hadoop, and later how we can use this Spark, what are the benefits that we are having. And here we are going to say these two are very, very, very important. RDD, resilient distributed data set. This is a core API of your Spark. And data frame, market is looking towards to the data frame currently, because we can have more options to improve the performance, or more easy to transform the data. When you go for RDD, it is not going to have that much things. And then we have a different kind of clusters. We are going to talk like job purpose cluster, all purpose cluster. So how exactly we can use that, we are going to see. And we are going to talk about a different kind of utilities, like how we can mount your data store, and how we can use the notebook utilities, widget utilities, file system utilities. So file system utilities are very important for data ingestion. Okay, so you can use the same Databricks itself to ingest the data from one place to another place. So you can go this, but the better approach is to go and use the ADF if you have. And some people, they may use Scoop also in order to ingest the data, but it's out of the boundary for us because we are having ADF. We can use the ADF to ingest the data. And different kind of data, how we can read like CSV files, JSON files, Avros, but mostly always we are going to have the data. If it is pure Databricks project, even currently I'm working completely Databricks project where we are using JSON data and Parquet data as a data sources. Only these two set of data only we are having it. So how we can apply transformations, what kind of transformations we can do as part of Databricks, that we are going to see more in detail. Okay, so that is about the content that I wanted to take you through. Just take the content from a team, and you can go through that for understanding, and we are going to cover more in detail about it. Yeah, so that's all about it. Still, if you have any question, you can talk to me.
Hi, Bhaskar. This is Sai. Am I
Yes,
audible?
I'm
Yeah.
able to.
Yeah. In one of article, I came to know that we need to have a knowledge on language. So, what kind of language we are using here, and
Python.
how much basic knowledge we need to have on that language? Because I'm very
Prerequisite.
new to Python. I'm very new to Python. So,
Basic SQL is required,
okay.
and basic Python is required. Okay, so Python
So,
is like anything. Okay, so not required to know about everything. So no worries, I'm going to take you through the basics of the Python. Okay, so whatever is related for data side, that we required. Okay, so you don't worry about this. And SQL also, I'm going to touch that, but if you can go through in many YouTube channels, you can have some basic SQL, you can go through that. But basic Python, I'm going to take you through that. So if you want to go through that in YouTube, you can just search for basic Python. So it's not required even. I'll take you through that.
Sure,
Uh,
sure. Thank you.
Yeah.
yeah, hi Bhaskar, Datta here. So, as you said, yeah, using this Azure Data Factory, we are gonna ingest the data and then we are gonna process the data, right? So, what is
Yes.
the end result of the processing? Like, so are we going to send that end result to again the ETL? So that's what you
No,
are saying, right?
reporting team. Reporting team will take.
So we are all so we are going to do the ETL too. Like, I mean, I have
We are the
seen
ETL developers only. Basically, previously we used to call them as the ETL developers. Now
exactly.
the market is changed. We are being called as data engineers.
Oh, so you're saying that we are the one who does the ETL and also we are the one
Exactly.
who deals with the backend data storing also.
Yes. 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 So previously
Oh,
known as ETL developers, now we are data engineers.
so here you're going to teach only Azure data engineering? I mean, in the sense you're also going to teach like talent or something else or
No,
else?
it's a data engineering role. Sorry, Azure data engineering role it is, not talent or any other services.
Okay, so in this like SSIS you said, right? So we are going to know that too or else no?
No, that's out. That's outdated. It is. We don't require to know it. If you have a basic knowledge, you can, but we are not going to touch that.
Okay, okay. So, I mean, I'm new to this one, so I
Yeah,
just know some information because of that
no
I'm
problem.
asking.
So they were like outdated ETL tools. Market is not looking forward them, and market is looking towards to this Azure Databricks, Azure Data Factory, and from Amazon Glue is there. But Databricks is common for every platform.
So here, the Databricks is going to process the data after
Yes,
ingestion.
yes, you're
Okay,
right. So what
okay. So,
Microsoft did again later is, because Databricks is coding, why don't we provide completely user interface to process the data? So Microsoft came with the data flow.
okay. So you're saying that instead of talent or whatever the ETL tools, the entire thing is being replaced by only Azure Data Engineering, right? Like ADF.
Exactly. You're right. You're right.
Okay, okay. Thank you. I mean, I was confused.
Hi,
That's the
Bhaskar.
reason why I was asking.
No problem. Yeah.
Hi, Bhaskar. This is Sridhar. So, what is the major difference between Azure data engineering and data management?
Data engineering and
Data management, Azure data management.
Azure data management. Looks like same, but I'm not exactly sure. Like data engineer is going to deal with the data. Data management, sometimes even data analyst also comes into that. Not exactly sure about it, but looks like more or less same.
To make a decision on it, what to learn or something, I just want to know what is the major difference between both of them.
Okay, so data management, I didn't hear that term, that role. I heard about solution architect to provide the solution for ETL, and resources solution architect will be there, and data analyst will be there. So data analyst is going to create the model. If I'm correct, data management is going to be like right after doing this ETL processing, we are going to um, create a modelings like a tabular model or a multi-dimensional model. So that will be coming under data management, if I'm correct.
Okay. Okay.
And yeah, sorry. And yeah, the data warehousing is also a part of data engineering, right, Bhaskar? Like, am I
Of
wrong?
course, of course.
So data warehousing is that like we are transforming the data from one source to another, like one format to another format. Is
Yes,
this
yes. That is what we are doing as a data
okay?
engineer.
Okay, okay.
Anyone else? Any question? Okay, then I'm stopping here and we'll see you soon. Thank you for joining. And if you have any, if you need any details, you can check with Career IT team. Thank you for joining.
Thank you, Bhaskar.